Okay, before proceeding to point 1 and 2, ito yung strength reduction factor phi. Ito yung kanyang computation kapag yung point mo ay nandito sa transition zone. Okay? So from points 2, 3, 4, 5, 6, ang capacity reduction factor phi ay 0.65. Okay? So ayan. Ito yung range ng strain T. Ito yung actual strain. And then, strain Ty, ito yung yield. This is equal to Fy all over 200,000. Okay, so take note na your strain is less than 0.005. Kapag greater than 0.005, okay, ibig sabihin, greater than 0.005, nandito ka na sa ilalim, ang capacity reduction factor phi is obviously 0.9. Okay? This is now tension controlled. Now let's solve point 1. Okay? So madali lang yung point 1 tsaka point 2. Yung point 1, diretso na tayo sa sample quiz. So ganito yung magiging homework ninyo. Magbibigay ako ng given. Ayan. The red is given 457 times 7.6. Yan yung concrete. Fy is 414 times and then clear cover. And then AS3, AS2, and AS1. Take note of AS3 and the numbering AS2 and 1. Meron tayong plot points. This is now PN and then PMN. Okay, ito yung example. So, point 1, PO is 0.85 F prime C, area gross minus area of steel plus Fy AS. Or that is 6,823 kilonewton. Now, let us solve this using calculator. 0.85 times 27.6 times the quantity area gross minus AS. Obviously, yung area gross mo, that is equal to the area of the concrete, 457 times 457, minus AS. Ngayon, yung AS mo, that is the area of all rebars, which is 8 pieces, 28 mm. And then plus FYAS. Notice na this is in Newton. You have to divide this by 1,000 para maging kilonewton. And then you have to multiply this by phi, which is 0.65, para maging 4435.21. Okay, merong nakasulat dito na plot. So, ibig sabihin, yan yung ikakopy natin, ipe-paste mo dito sa point 1. Okay? Obviously, at point 1, walang value ang PMN. Ganon din sa point 2, walang value ang PMN. Now, let's go to point 2. This is the equation for point 2's 0.8 times P times area gross. Notice na this is 0.8. Kapag round column, I think this is 0.7. Now, your rho G here, that is simply your steel ratio, that is AS all over area gross. Okay? So, ito yung kanyang solution. 0.8 times P times area gross times the quantity 0.85 F prime C plus rho G. Ito yung area of steel, 8 pieces times pi diameter of bar square all over 4 divided by 457 squared. Okay, so dinivide ko siya ng 1,000 para maging kilonewton. Okay, so note that Pn or this is the nominal axial capacity, is 5,458.72 kilonewton. Okay? Next, we now go to point 3. Before going to point 3, etong 3548.17, yan ang ilalagay natin dito sa point 2. Okay? Yan, 3548. Now, let's go to point 3. Remember na point 3 is maximum moment strength at maximum permissible axial compression. Okay? So, ganito ang kanyang stress diagram. Okay, point 3. Lahat naka-compression siya. Pati yung steel compression pa rin. Yan. Okay? So, ang assumption mo dito, ito yung this is the distance of the neutral axis to the extreme compression fiber. Now, look at the figure. Sa reinforcing steel bar, sa beam, di ba? Yung AS nandun sa ilalim. So, since we have 3 layers, yung first layer na nasa baba, yan yung AS1, tapos pataas, AS2, and then finally, AS3. At then we have the centroid of rebars. This is X1, the centroid of AS1 from the top, and then X2, the centroid of AS2 from the top. Finally, X3, the distance of the centroid of AS3 to the extreme compression fiber. Okay, and then, ito yung compression concrete. This is defined by this area, which is equal to A. Note that A is equal to beta times C. Ito yung C. Okay? So, now what are the forces acting at this section? Or what are the forces resisting your axial load and moment? So, ito yun. Meron tayong compression concrete. Meron tayong compression due to steel 3. And then, compression still due to steel 2. And finally, compression due to steel 1. Okay? And then, let's solve. Compression concrete is 0.85 F prime C multiplied by the area of rectangular block, which is beta C. Yan. Ito yung A multiplied by B, which is 457. But then, we do not know the value of C. So, ganyan lang muna siya. And then, for your steel, CSI, compression due to steel 1. Meron siyang equation na AS1 times FSI or FS1 minus 0.85 F prime C. Okay, so minus natin yung 0.85 F prime C. Ito yung area na na-displace nung steel. Okay? Ngayon, due to the strain diagram, due to similar triangles, look at this. Okay? Remember na stress, Fs, is equal to strain times elasticity. At yung strain mo, ito. Okay? So, by ratio and proportion, Fs is equal to strain times 200,000. What is strain? Dito tayo sa strain steel 1. By ratio and proportion, strain in steel 1 all over this distance. Ano itong distance na yan? It is equal to your C minus x1. Okay? This triangle, nanggaling yan dito. Okay? So, strain in steel 1 and then this distance, that is equal to C minus x1. Ayan siya. Okay? This is similar to the bigger triangle which is defined by C tsaka yung strain ng concrete. Ito, this is always 0.003. So, similar triangles yan. Okay, so strain is still 1 all over C minus x1. Horizontal all over vertical is equal to 0.003 all over C. So, by cross multiplication, strain in steel 1 now becomes ito. Now, you substitute strain in steel 1 dito para magiging stress now is equal to 600 times C minus x1 all over C. So, nanggaling yung 600. It is 0.003 times your elasticity of steel. So, going back here, still, your C here is unknown. By the same triangles, but this time we will utilize strain in steel 2, your compression steel 2 is this equation. Take note na nag-iba lang yung x1, again x2. Okay, and then let us also compute your compression in steel 3. Note na compression in steel 3, dito na yan, masyadong malaki na yung strain, okay? So, this is strain 1, this is strain 2, masyadong malaki na yung strain 3. So, this is about to yield. So, ang gagamitin na natin ngayon is Fy na kagad, okay? Ayan. So, CS3 is equal to AS3 times the quantity Fy minus 0.85 F prime C. But, you can always check. Next is, we will now add all these forces. Okay? Ito na siya ngayon. So, nakalagay na dito ngayon yung compression steel 3, compression steel 2, compression steel 1, tsaka yung compression concrete. So, ito na siya. Okay. Now, we will add all of them. Okay? Take note na lahat sila is compression. So, summation lahat yan. Ito yan. Okay? CS3 plus CS2 plus CS1 plus CC is equal to your nominal axial force PN. But take note na yung PN, that is taken from point 2. Okay, what's the value of PN or nominal axial force from point 2? Ito yun. 5458.72. Okay? Next. So, you now equate that here. So, ang matitira na lang dyan na unknown is yung small c. So, by quadratic equation or ship solve, okay, you will get a value of 467.06 millimeter. And then you substitute this value of C dito sa mga forces na yan. So, you will get now compression concrete 42.56 up to compression steel 1 132.42. If you would add all of this as a check, it should give you the same value PN. And then, isa na lang ang kulang natin, yung moment. Now, you take moment at center of column